Hello friends, welcome back in the video lecture series. Today we will see the remaining part of the analytical chemistry chapter, and the title is errors in quantitative analysis. In last video lecture we have seen the concept of significant figures and computations. In that we have also seen application of that significant figures and computations in doing some mathematical operations such as addition and subtraction. Only the remaining part of that concept we will see today, and the last topic of this chapter we will see in this lecture, and that will be the end of this chapter. Okay, so let us start with a familiar rule. This rule is familiar to all of us, and the title of the rule is rounding off rule. So rounding off rule is very important in case of significant figures. Okay, so what is rounding off rule? It is very easy. In the results, when we are getting results, and if your value is having more decimal points, if your value or result is having more decimal points, then we contract that result, or we may reduce the number of figures, number of digits in your result or answer, okay, by using this rounding off rule. Okay, so what is this rule? If the last digit is 5 or greater, if the last digit is 5 or greater, then the previous digit should increase by 1. Then the previous digit should increase by 1. Okay, so if the last digit is 5 or greater, then the previous digit should increase by 1, or if it is less than 5, then that digit can be dropped. So this is a very simple rule that is known as rounding off rule. We are rounding off that result or that value to a smaller number of significant figures, to a smaller number of digits. This is the rounding off rule. If you look after these examples, then you will find out then what is meant by this actual rounding off rule. Okay, for example, let us see here 12.386. The figure is 12.386. Now after decimal points there are 3 digits, 1, 2, 3. Okay, so I can write this number in rounding by the use of rounding off rule, like, so the third digit after decimal point is 6 and it is greater than 5. Okay, so as it is greater than 5, so we can increase one number to the previous digit. So previous digit is 8, and so that's why 8 plus 1 we can write here 9. So rounding off, by using rounding off rule, the rounding off number is 12.39. Or but if the number is 12.384, so the third digit after decimal point is 4 and it is less than 5, so that's why we can discard this, or we can ignore this number, and the rounding off number of this number is simply 12.38. So this is the difference between these two numbers. If it is 12.38567889, okay, means it is less than greater than 5 or more, then one number is increased in the previous digit, and so we can obtain the result like this. Okay, but if it is less than 5, then the rule, the last digit can be neglected or can be dropped. This is a very simple rule that is known as rounding off rule. Okay, now the next point is application of the significant figures in multiplication and division. In last lecture we have seen the application of addition and application of significant figures in multiplication and division. Application of significant figures in multiplication. I hope all of you have seen the last video lecture on YouTube, that what is the actual concept of significant figures. Okay, if you get that point, significant figure, how to calculate the significant figure, then and then you can apply this concept in addition, subtraction, multiplication and division. Okay, so today first of all see this application in the multiplication and division. Okay, now in multiplication and division, one more additional rule is there as compared to addition and subtraction. Okay, so what is that rule? In addition and subtraction, we have seen that whatever the given numbers for addition and subtraction are given in your problem or in your result. Okay, so depending on the least number of significant figures in your given data, that only numbers or significant figures are allowed for the remaining numbers. But in case of multiplication and division, 1 plus or plus 1 digit or plus 1 significant figure is allowed for the remaining figures in the calculation. Means what? The rule is very simple. Whatever the least significant figure in given numbers or in given, let us say, values, we can take plus 1 significant figures. This is very important for remaining values for the purpose of calculation. Okay, for hearing and for learning this rule, it is quite difficult or it is quite critical, but if you look the examples, then you will got very easily. Okay, so I am taking one example. For example, so the example is 12.3 into 0. You can take any example. For the simplification, I have summarized all these rules on paper and trying to explain you. 0.5784, because calculations are there in this topic, so that's why by using again calculator, so it will take time, it will time consuming process, so that's why I am shortlisted some of these rules on paper. Okay, so this is a very simple multiplication, 12.3 into 0.5784. Now you may be surprised that you may be you might be thinking like that, we are learning in SYBSc, and why such numerical problems based on multiplication, which is at 3rd or 4th standard level, are given in our syllabus. But the concept is not like that. The concept is different. The concept is significant figures. Okay, so on the basis of this significant figure concept, you have to solve this numerical problem, that is multiplication. Okay, in your exam also the numerical problems based on this may be asked. Okay, so that's why the concept should be clear first. Okay, now you may be able to find out the number of significant figures in these two numbers. Okay, so the significant figure in this is 1 2 3, all the 3 digits are significant. So the number of significant figures in this number, it is 3, and in this number this 0 is not significant. So 1 2 3 4, all the 4 digits after decimal points are significant. Okay, so this is a multiplication. So number of significant figure for this is 3 and for this is 4. Okay, what is the least significant figure? It is this 3. Least means lowest significant figure is 3. Now in case of addition and subtraction, what is the rule? Only the numbers we can add or subtract for the least significant figure. Okay, but in case of multiplication and division, plus 1 significant figure is allowed for remaining numbers. So for this number it is 3, and 3 plus 1 is equal to 4. So the 4 significant figures are allowed for the remaining numbers in calculation. So for this number is remaining number, and for this number 4 significant figures are allowed. Okay, as per this rule, 3 plus 1 4. So 1 2 3 4, all these 4 figures can be allowed for the multiplication as per this rule. Okay, so the answer is the product of this is product. What is the product? 7.11432. You can use your calculator and calculate this answer. 7.11432. This is the product of this multiplication. Now, how many significant figures are there? 1 2 3 4 5 6. Significant figures are 6. Significant figures are 6 in the product, but this number is higher than the least significant figures in your numerical problem, and it is 3. So only 3 significant figures are allowed in your answer, in your product. So the correct answer is according, so no doubt this answer is also correct. This answer is also correct as per our general mathematical rules, but as per the concept of significant figures, this 7.11432, this whole number is not allowed as a correct answer. So what is the correct answer? The allowed significant figures in the product are only 3. So the answer will be 7.11. Answer will be 7.11. 1 2 3 significant figures in this number is 3, which is allowed as per the rule. So this is the concept of significant figures in multiplication. Okay, now for your simplification I am taking one more example, and after learning that example problem, you will be able to solve the problems based on this concept. Okay, very easy. Look this, see this video 2 to 3 times. You will be able to find out the answer based on this concept. Okay, now the next number is next problem is 1.34 into 1.389 into 0.5868. This example is again from your textbook, but what is the actual explanation that we have to write, see here, into 22.7642. Don't read your textbooks based on this concept. It is very critical, very tedious, and it is not getting properly in your mind while reading this. Okay, see this video 2 to 3 times, more times. Okay, then and then you will get the proper meaning of this concept. Okay, now so this is the problem. 1.34 into 1.389 into 0.5868 into 22.7642. Okay, so how many numbers are given? 1 2, 3 and 4. Okay, now we will see what are the significant figures in each number. Significant figures in this number is 1, 2, 3. All the three numbers are significant. In this 1, 2, 3, 4. In this G0 is not significant. 1, 2, 3, 4. 4. And in this figure 1, 2, 3, 4, 5, 6. Significant figures is 6. Okay. So what is the least significant figure, LSF? This is not a short form. I am writing here short only. Least significant figure is 3. This one, lowest is 3. So what does it mean as per the rule? +1 rule. As per the +1 rule, only 3 + 1 least significant figure is 3, and as per the +1 rule, 3 + 1 is equal to 4 significant figures. 4 significant figures are allowed for the remaining numbers in your calculation. Okay, so this numerical problem can be written as per this rule, +1 rule. This numerical problem of multiplication can be written in such a way that 4 significant figures are allowed in each value. Okay, 1.34, 1, 2, 3 allowed into 1.389 allowed. Why? Because significant figures is 4. Again this number is allowed 0.5868, but this number is not allowed as a whole. 22.7642 is not allowed. Only the 4 digits, 4 significant figures allowed. Okay, so it may be reduced as 22.761234. Only up to 6, 1, 2, 3, 4. 4 significants are allowed in this number. Okay, so my numerical problem is changed to this, and the answer of this is the product of the multiplication of all these 4 number is 24.85. you can use your calculator. 8581845. 24.8581845. so this number is the product of multiplication of all these 4 numbers. Okay, but this is not a correct answer as per the concept of significant rule. This answer is correct as per general mathematical rule, but this is not correct as per concept of significant rules, significant figures and computation. Okay, so how many what is the significant figure? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 significant figures are there, but only 3 significant figures are allowed while writing the answer of this multiplication as per this rule. Okay, so the correct answer is 24.8. Now the next digit after 8 here is 5. After 5 it is 8. Okay, so let us concentrate on 5. So this 5 is greater number. Okay, or as per the rounding off rule, the next number is 5, so it can be rounded off to 85 can be rounded up to 0.85 can be rounded up to 0.9. Okay, so the correct answer is 24.9. 24.9 is the correct answer of this multiplication. Okay, so I think with the help of this example given discuss here, you will be able to write or solve the problems based on the significant figures. Okay, now the last point is the application of significant figures in division. Now we will see some problems of division, then you will be write or obtain the results as per the concept of significant figures. Okay, now What is the problem? 63.21 divided by 0.012. So this is a very simple problem. 63.21 divided by 0.012 divided by 0.012. Okay, tell me the number of significant figures. Number of significant figures in this. All 4 numbers are significant. Okay, but in this case this 0 and this 0 after decimal point are not significant. Okay, only the 2 digits 1 2 are significant. Now why these 2 significant figures are these 2 digits are significant, that we have already discussed in the previous lecture. Okay, so it is not the time to explain this. Okay, so now the least significant figure is 2. Least significant figure is 2. Now what is the rule? Plus 1 rule. This is the systematic way to solve the numerical problems based on this concept of significant figures. Okay, this is not given in your text. Plus 1 rule. So what is the least figure? 2 plus 1 is equal to 3. So only 3 significant figures are allowed in your calculation for the remaining numbers. So the least significant figure number is 0.012 and the remaining number is 63.21, and for this number, according to plus 1 rule, only 3 significant figures are allowed. Okay, but this number is having 4 significant figures. So my numerical problem can be written as 63.2 divided by 0.012. Got it? Very simple. Why it is reduced to 63.21? Why it is reduced to 63.2? According to plus 1 rule. Okay, now the answer of the division of these 2 numbers is 5.266 into 10 raised to 3. 5.266 into 10 raised to 3. This is the division obtained by using calculator or calci. Okay, but as per the least significant rule, the correct answer is, okay, so what is the least significant? Least significant figure is 2. So okay, we can write only 5.2 into 10 raised to 3. 5.2 into 10 raised to 3. This is the correct answer, because 5.2 the significant figure is 2. This 5 and 2, these 2 only the significant figures are there. Okay, so this is the concept of significant figures and computation, and on the basis of that we have solved some numerical problems such as addition, subtraction, multiplication and division. Okay, so this is all about very critical and not getting properly. If you go through your text or references, this concept you will not get properly, but to get this concept, kindly watch this video 2 to 3 times. Okay, then the last concept is reliability of results. This is the last concept of your chapter, reliability of your result. So what is meant by reliability? Reliability is nothing but trustability. Trust. Reliability of results. Reliability of results. So what is meant by reliability? Reliability means assurity or trustability. Okay, trust on the result. Okay, now analysis of the results can be considered into 2 main categories. analysis of the result can be considered into two main categories. The first one is the reliability of the result. The first one is, I am not writing repeatedly, just same as the above. Okay, so the first thing, analysis of any result can be categorized into two main categories. The first one is reliability of the result, and the second one is comparison of the result. Comparison of the result with true value. Comparison of the result with true value. Okay, now we are not discussing the second point, that is comparison. We are looking only on the reliability of the result. So analysis of any result can be categorized into two main parts or two main categories. These are reliability of the result, that is trustability of the result, and the second one is comparison of the result with the result obtained from any analysis can be compared with the true value of the result. Okay, so this is the idea of analysis of the result. Now in reliability of the result, in case of reliability of the result, how we can rely or to keep a trust, how we can rely or keep a trust on the obtained result or getting result. Okay, so there are certain statistical tests should be there, certain statistical tests should be there to check whether our values or results are reliable or not. Some statistical test must be there, should be there to check whether our results or values obtained for that analysis are reliable or not. Okay, so if you are getting number of values, number of results for particular analysis, then some values may be discarded, some values may be neglected. Okay, the reason for that must be clear. Okay, so one cannot discard any value or any result depending on that desire of that particular person. Okay, so there must be a statistical test. By using this only we can check whether that value could be rejected or retained. Value or result rejected or retained. Retained means keep as it is in the analysis, retained. So this judgment can be done with the help of some statistical test only. Then and then, or there should be a reason. There should be a reason. Reason for what? For discarding or rejecting that particular value. The reason may be chemical reason or instrumental reason. Okay, then and then we can discard or reject that value, otherwise not. This is the concept of reliability of result. We will see this concept by taking an example. Okay, so take an example. So a sample is tested for the cadmium content. Cadmium is the metal and for that a sample is tested. Cadmium content of the sample. The analysis is done for the cadmium content, and the values obtained are 4.3, then 4.1, then 4.0 and 3.1. All these values are in microgram per gram of sample. So 4 values are there, namely 4.3, 4.1, 4.0 and 3.1. Okay. Sorry, 3.2. So 4 values are given, and all these values are the cadmium content of the sample, and they are in microgram per gram of the sample. Okay, so how much microgram of that cadmium is present in per gram of that sample? These are the analysis results. Okay, now in these 4 values, the question is that whether the value 3.2 microgram per gram should be rejected or not, rejected or retained, we can say rejected or retained. This is the question, whether this 3.2 microgram per gram, this value obtained after analysis, should we reject or retain from this analysis? That is the question. We are learning this example for recognizing or for taking or learning the reliability of result concept. Okay, now this can be done with the help of a Q test. This Q test is nothing but a statistical test. We are not going in detail about this Q test because this is all related to statistics, one of the branch of mathematics. Okay, Q test. So this is a Q test for 4 samples, 1, 2, 3, 4. Now as per this Q test, how will you calculate this Q value? Okay, in mode, the questionable value minus nearest value, questionable value minus nearest value, this is in mode, divided by largest value minus smallest value, Okay, so in mod, the Q, we are calculating the Q value for these results. The questionable value is 3.2, in mod 3.2, minus, which is the nearest value, 4.3, 4.1 or 4.0. The nearest value of the 3.2 is 4.0, divided by largest value is 4.3 minus smallest value is 3.2. Okay, now as the above numerator is in mod, so the answer is positive 0.8 divided by 4.3 minus 3.2, it is 1.1. Okay, and the division of this 0.8 divided by 1.1 is 0.727. Okay, so the Q value obtained from this calculation is 0.727. Now the critical Q value obtained for these 4 samples from the Q table is 0.831. Now how this figure 0.831 comes, that I also unaware about that, because this is totally related to the statistics. This value is directly taken from that Q table. Okay, don't go in detail. Okay, this is only for our simplification or understanding purpose. So critical Q value for these 4 samples is 0.831. Now what the rule say? What the rule tells us? The rule tells us if calculated Q value is greater than, or if it is exceeds than the critical Q value, then we should reject this questionable value 3.2. We should reject this questionable value 3.2 when the calculated Q value exceeds or greater than the critical Q value which is taken from the Q table, okay, from the statistics. Now here the calculated Q value is 0.727 and the critical Q value is 0.831. Okay, sorry, here is a reverse. If the calculated Q value is greater than the critical Q value, if the calculated Q value is greater than, or if it is exceeds than the critical Q value, then we should reject that questionable value. Now here the calculated value is 0.727 and it is less than the critical Q value 0.831. So that's why, as it is less than the critical Q value, we should not reject the questionable value 3.2. Means we should retain this questionable value 3.2 in the sample. Okay, so all these 4 samples should be retained in your analysis, that is 4.3, 4.1, 4.0 and 3.2. Okay, so this is the concept of reliability of results. Okay, in other words, we can say that if we have more number of samples related to this, more number of samples, let us say 5, 6, 7, 8, 9, any, and we are calculating the Q value for these given results, and in second case I am telling, in that case, if the calculated Q value is greater than the critical Q value, then in that case we should reject that questionable value 3.2. okay, this is either or neither or like that. Okay, so this is all about the concept of reliability of results. In this way we have completed all the contents, all the topics from the chapter errors in quantitative analysis. Okay, now summarizing all this chapter from the first lecture up to this, what we have studied the definitions of accuracy and precision, then the detailed explanation or the concept of accuracy and precision we have also seen. Then the next point was methods of expressing the accuracy and precision. Okay, so the accuracy can be expressed in either of ways, that is absolute error and relative error. Okay, but the precision can be expressed in number of ways, that is deviation, mean deviation, standard deviation. Okay, these are the different ways to express the precision. Okay, and the number of different formulae are there, and we have used all these formulae to calculate the to solve the numerical problems based on this. Okay, we also seen the numerical problems based on this. Then the next problem is types of errors. What are the types of errors? There are mainly 2 types of errors, that are determinate and indeterminate errors. Determinate errors are again of 5 to 6 types. but indeterminate errors are only having only one type, that is indeterminate or non-systematic errors. They are also called as random errors, accidental errors, etc. Okay, 10 types of errors. After that we have seen the methods of minimization of error, minimization of errors. In that also we have seen the number of methods, different methods, how to minimize, how to eradicate these errors, that we have also seen. Okay, and the next one is concept of significant figures and computation Okay, in that we have seen the concept of this and application of these significant figures in the mathematical operations such as addition, subtraction, multiplication and division. And the last topic was reliability of result. Reliability of result. So this is all about the whole chapter that we have completed here today, and I think all of you are getting properly the meaning and the concepts regarding this chapter, that is errors in quantitative analysis. Okay, go through all videos, and some part of this we have also taken in online classes. Okay, so have a good day and thank you very much.